This is not a live video. This is just I just uh, sitting and thinking what I need to cover today in my fifth video of the series Maxwell equation, where started physics from foundational level. Four videos. I already uploaded four video of the series Maxwell 1, 2, and 3. I think uh, becomes live from today evening. So the today's topic is yes. Today's topic is our Maxwell equation 5. In this video, we will discuss about the straight line motion and circular motion. Why straight line motion and circular motion today? Because we have already studied till the equation of kinematics. These equations are applicable to situations. So the simplest situation or simple situation is a straight line motion. Then we discuss something about just on definition level, what is a circular motion is, where all these equations are applicable. Why circular motion? Because circular motion has these kinematic equation in different kind of notation. The circular motion, which has also equation of kinematics in terms of angular velocity. So these are things that we will discuss in few minutes. One of the different thing for today is a new tripod. It's not new, but it's
So here I am for fifth video. I tried to add.
oh sorry, I didn't attach my. So I think sound is clear now. In last class, I have described you about equation of kinematics. In this video, in Maxwell equation 05, we would see the straight line motion and circular motion in the light of equation of kinematics that we already derived in our last video, Maxwell equation 04. So what are different things we have to discuss in this video? First, suppose a straight line motion. Mean straight line motion is suppose an object moving in this direction with some velocity v in a on a straight line. Okay, then these equation that we have learned in our last class, v u plus at and s ut plus half at square and v square is equal to u square plus 2as are applicable. And in case of, first I give you an example of straight line motion. One example of straight line motion where acceleration is also involved, example, is suppose earth, as you know, anything that falls to it, falling by acceleration equal to g. G is a constant equal to 9.8 meter per second square. Means uh, whenever something drops in a 1 second, acceleration it feels is 9.8 meter per second square. Means the velocity increases every second when an object falling towards earth, and similarly when something is pushed up in the direction of atmosphere, then its velocity decreases with every passage of every second of a time. by 9.8 meter per second. So this is an example of gravity acceleration, straight line motion. The this is very easy, but second thing, which is a circular motion, the equation of kinematics also can be written for a circular motion, but with some difference. Suppose something revolving on this path about this center. Suppose in this direction. If objects here at some time, its velocity is in this direction, and if it object is here, the direction of velocity is this. And similarly, in outward inward direction for this part. So the velocity changes at each and every point during this motion. Sorry, I didn't explain you what is a circular motion. Circular motion is a very simple motion of an point mass about an axis. Suppose something is something a very small object or a very light object revolving around some axis passing through some point on a fixed radius, then the motion of this particle is regarded as circular motion. In circular motion, the direction of velocity is changed at each and every point. So the velocity in terms of direction is not uniform. But the suppose its magnitude is constant. Suppose its magnitude is 10 meter per second. So the 10 meter per second remains, but the direction of this 10 meter per second change in each and every point. Therefore, we can say the velocity is not constant, but speed of this motion is constant. So as the speed of this thing is constant, we can write the equation of kinematics in the scalar form. Here a different thing, also a thing comes, which you may heard or not, is a angular velocity. Instead of measuring this velocity, this is called tangential velocity, which is not constant because its direction is changed, but its magnitude for a uniform straight line motion is constant. For uniform straight line, no, it's a uniform circular motion. For uniform circular motion, the magnitude is constant. What is angular velocity? The angular velocity is not measured in terms of linear displacement. It measured in terms of angle when this point mass makes when it revolves around this axis. So it defined as omega. This letter is seems you W, but it is called omega. This is equal to the angle traced upon time it takes, or in differential form d theta by dt. So the displacement is replaced by the angle, and this velocity is now called angular velocity. Obviously, this is also a scalar quantity because angle does not have any direction unless you define. So we can write equation of kinematics in terms of this letter. Also, there is angular acceleration. Angular acceleration denoted by alpha. So you can write the equation of kinematics for circular motion as omega 2 is equal to omega 1, as we use u and v notation in uh, straight line motion. In case of angular motion, you can use 1 and 2, or there is another notation. For initial we write naught, and for final we write omega into alpha t. Its acceleration is replaces by the angular acceleration. The second equation, now displacement is replaces by theta. Initial velocity becomes omega t half alpha t square, and omega square is equal to omega square 2 theta alpha. So only notations change, the meaning remains same, but the motion is now a circular motion, not a straight line motion. There are also some formula which can be helpful. This topic is discussed in a number of times during this syllabus with different context. Here I am just introducing this motion. Later we will discuss this for different aspect of this motion. A formula is a tangential velocity is related to angular velocity as in terms of magnitude, and acceleration, there is also formula for acceleration. Acceleration is also omega v, yes, or a omega r square. So these are some basic formula which you have to know in case of circular motion related to equation of kinematics. So this is the topic of today's video. Now I'm ending this, otherwise this video becomes so long.